The Su-47 fighter plane, which used to be called the S-37 Berkut or Golden Eagle, was made by the Sukhoi Design Bureau in Moscow, Russia. It took its first flight in September 1997. The Su-47 has wings that are swept forward, and its aerodynamic design is based on a triplane with three main lifting surfaces that is very unstable. Some of the Su-27's systems and parts were kept, like the design of the canopy, landing gear, some of the avionics, and the almost vertical tails. In today's video, we will discuss Russia's plane with backward wings, the Sukhoi Su-47. But first, subscribe to our YouTube channel and press the bell icon for all the latest updates. Su-47 development details. The Su-47 was first shown to the public in January 2000, and the first round of flight tests was finished in December 2001. At speeds below the speed of sound, the Su-47 is very agile. In May 2002, Sukhoi was chosen as the main builder for the Russian PAKFA fighter program for the next generation. The PAKFA fighter plane is based on the Su-47, but its wings don't curve forward. The first test flight for the PAKFA fighter plane was on January 29, 2010. The very high maneuverability prototype is based on the avionics and aerodynamics technologies developed for the Su-27 upgrade program. The plane didn't go into full production, and the only one made was used to show how the technology worked. It is where the Su-57, a fifth-generation stealth fighter that can fly faster than sound and doesn't leave a trail, is made. In August 2019, the Su-47 Berkut was shown at the International Aviation and Space Salon Maycast 2019 at Moscow's Zhukovsky International Airport. Su-47 maneuverability. The Su-47 is very maneuverable at subsonic speeds, which means it can quickly change its angle of attack and flight path. It is also very maneuverable at supersonic speeds. The Su-47 plane is very easy to move around, and it stays stable and easy to control from any angle of attack. When it comes to combat superiority, the maximum rate of turn and the upper and lower limits on airspeed for weapon launch are important factors in close combat, as well as at medium and long range, where the mission may require shooting at multiple targets in different parts of the airspace. The Su-47 can turn quickly, so the pilot can quickly move the fighter plane to the next target and start the weapon launch. A swept forward wing of the same area has a number of advantages over a swept back wing of the same area. It has a higher lift-to-drag ratio, more capacity in dogfight maneuvers, a longer range at subsonic speed, better stall resistance and anti-spin characteristics, better stability at high angles of attack, a lower minimum flight speed, and a shorter distance to take off and land. Su-47 fuselage. The cross-section of the Su-47 fuselage is oval, and most of the airframe is made of aluminum and titanium alloys. Only 13% of the weight of the airframe is made of composite materials. The front part of the nose radome is slightly flattened and has a horizontal edge to help keep the plane from spinning. Forward swept wings. The Su-47 looks different and unique because its middle wing curves forward. The part of the forward swept wing that is closest to the plane is where most of the lift is made. Wingtip stall doesn't make the lift go down. The ailerons, which are the wing's control surfaces, work even at the steepest angles of attack, and the plane can still be controlled even if the airflow breaks away from the rest of the wing's surface. Almost 90% of the Su-47's wing panels are made of composites. The midwing is swept forward and has a high aspect ratio, which helps the plane go far. The wing panels have flaps and ailerons on the leading edge and deflectable slats on the trailing edge. The leading edge root extensions flow smoothly into the wing panels. The leading edge root extensions are connected to the trapezoidal canards that move all around and have a small surface area. Armament. The experimental fighter plane Su-47 has 14 hardpoints, 2 on the tips of the wings, 6-8 under the wings, and 6-4 under the fuselage. Air-to-air missiles like the R-77, R-77PD, R-73, and K-74 are mounted on the hardpoints. It also has the X-29T, X-29 liters, X-59M, X-31P, X-31A, KA-B-500, and KA-B-1500 air-to-surface missiles. Su-47 Berkut cockpit. The cockpit was made so that the pilot can be as comfortable as possible and still be able to control the plane when it is going through very high load maneuvers. The plane has a new life support system and a seat that can be used to jump out of the plane. The pilot is less affected by high G forces because the variable geometry adaptive ejection seat is tilted at an angle of 60 degrees. The seat lets the pilot do dogfight maneuvers with much higher loads than he or she could normally handle. The pilot has a low travel control stick on the side of the plane and a tensometric throttle control. Landing gear. The plane has landing gear that looks like a tricycle and has a single wheel at each unit. The smaller nose wheel moves back toward the back of the plane, and the two larger main wheels move forward into the roots of the wings. Engine. The two Perm avionics LD-30 F6 turboshaft engines power the Su-47 fighter plane. About 83.4 kN of dry torque can be made by each engine. The engine is used to move people in short-distance passenger planes. The length of the engine is 3.98 meters and the diameter of the fan tip is 1.05 meters. The engine weighs 1,550 kilograms when it is dry and 1,712 kilograms when it is delivered. The engine also has a low-pressure compressor and a device that changes the direction of thrust. Su-47 performance. The fighter plane Su-47 can climb at a speed of 233 meters per second. The speed for cruising is 1,800 kilometers per hour. The plane has a range of 1,782 nautical miles and a service ceiling of 18,000 meters. The plane can take off with a maximum weight of 34,000 kilograms. The Su-47 has a maximum wing load of 360 kilograms per M2 and a maximum force of 9 grams. The use of composite materials. The swept-back wings have a lot of benefits, but it's hard to make them because the whole structure can break when the plane gets to a certain speed. Using composite materials made it possible to make things that are very stiff. Composite materials are now frequently used to make aeroplanes. At the time, Berkut laid the groundwork for developing these technologies, which, by the standards of the 1990s, was a major step forward. The reverse sweep wing of the Berkut was made by Obninsk Research and Production Enterprise Technologia, which is part of Rostec. The panels were made with a new material made by VIM that was better than the best in the 1980s. Still, the plane was able to use a number of design and technical innovations that had never been used before in planes of this type. This means using longitudinal static instability, making large milling panels with double curvature, using composite materials in loaded airframe structure elements, and so on. But there are some major problems with wings that move in the opposite direction. Planes with wings that move in the opposite direction have unstable flight characteristics. Most of the stress on the wings comes from going fast. Because the weapons added 18 tons to the weight of the Su-47, its G-load capacity was also limited. The cost of keeping this up would have been out of this world. It was also very good at making quick turns, but it had trouble keeping its speed when making long turns. The plane was expected to move at Mach 2, but Berkut found that it went the fastest at Mach 1.65. At the same time, only one Su-47 was seen at air shows, which made some people think that the company that made it wasn't too sure about it. Still, the plane was a big part of how the Su-57, Russia's fifth-generation fighter jet, came to be. The Su-47 also gave Russian plane makers a chance to test out some important ideas and learn more. That's it for today. We hope you found our video interesting. If you did, please give it a big thumbs up and share it with others. Also, if you haven't already, please consider subscribing to our channel. Don't forget to turn on the notification bell so you don't miss any of our new uploads. In the end, thanks for watching, and see you next time.